Let's get started to a session about shell coding, hardcore coding, hopefully. My name is Roland. I'm coming from Red Hat. I'm a software engineer, so I'm really a developer. And yeah, most of my time I'm writing tools for Kubernetes, like the Fabricate Maven plugin, Docker Maven plugin, so Java tooling for Kubernetes and OpenShift. And the other half of my time I'm working on a product called Fuse Online or Synthesis. I'm not sure whether you ever heard about it. It's about enterprise application integration, the fancy thing which connects end system to each other and makes transformations. So this has nothing to do, not so much to do with shell coding, but actually it has to some extent. There is some overlap because we are using kind of homegrown build system and have written this build system in shell. I will explain the reasons, of course, why it is. And yeah, and what I'm going to do now today is I'm going to share you my experiences I gained there. So we had these very huge shell scripts, and of course there are some traps and pitfalls you should be aware of. And yeah, this is the talk. The talk is in the category slideless. So actually, I can ask me really to do it without any slides, which is, by the way, the first time I do this. So actually, yeah, wish me luck for that. Yeah, but first of all, the first question, of course, is who of you are really liking writing shell code? Oh, that's a lot. That's a lot. I didn't expect that much. So approximately 1/3 really likes writing shell code. That's good. And but I guess the other one do not really like it. And I hope that I can give you some reasons and some help to a little bit to decrease the pain you have when writing shell coding. Okay, but first of all, the motivation of the first question is why do we want to write shell script at all? And yeah, so actually, by the way, this is a kind of interactive session. So if you have questions, just post them immediately. So I will make some live coding. I will make many faults probably, and I'm very glad if someone steps up and says, okay, there's some error, or what helps me in that case. Thank you. So first of all, why? So first of all, yeah, why? One of the main reasons is that shells are everywhere. So it's very ubiquitous. So you find shells in every container, and especially in the container world, which is of course Linux-based, you find shells you have shells as a part of the operating system. So you don't have any issues with installing some stuff in addition. So shell is everywhere. And the reason why we used shell for coding was that at first we thought about, okay, let's do it in Go. But then half of the team doesn't know any Go. Then let's do it in Python. That's the same issue. And then my idea was, of course, to write it in Perl, because Perl is my favorite language, actually. So it's even worse. So maybe we switch later on to Perl. No, just kidding. So actually, this was, of course, a no-go. So and at the end, we ended up to say what kind of scripting language everybody really knows, and we ended up with shell. So shell is the least common denominator everybody knows. And this is the reason why we settled on shell. So yeah, everybody knows it. Denominators, okay. And this is a good thing. Actually, yeah, so everybody knows a little bit of shell. And we will see later that if you don't introduce a kind of rules, then you end up in some really pile of something. Yeah, so actually it's then about conventions later on, and I will show you some of the conventions we are using. These are probably not universally applicable, but might be useful for you as well. Let me close that one here. Okay, and then another big advantage, of course, that shell is scripted. So you have very quick turnaround times. If you want to try out something, you can easily just write the shell script, try it out, fix it if there's a syntax error, and so on. So you have very quick feedback loops, which is really very nice when you are developing incrementally and interactively. This is what they call REPL and so on. So it's quite useful there. So this is actually the reason is, so this is why we probably should know at least some shell code. And before I go into the example, so we are going to write a little shell script then, or a little command part, some words about the history of shell. So the first shell was, of course, the classic shell, SH, was written by a guy called Ken Thompson. And anybody knows when this was the case? Any idea? 1970, very close. So actually it was 1971, but yeah, so this was part of the original kind of Unix system. And when they started, it was just for CLI usage. And even all the control structures we know, like if and for and so on, were kind of commands. So this were not intrinsic parts of the shell. It was just some extra commands which were called there. They already knew about input and output redirection, which is very nice. So if you know, if you write a shell, you can redirect the standard error and the standard output. Actually, it's also interesting what was not there yet at the time, and there were no variables yet, and especially there were no pipelines. So the concept of Unix pipes were introduced a little bit later. Okay, maybe I go a little bit up. Let's see. Yeah, so this was the first shell. It was quite nice, and people really used also them for, although it was not really targeted for coding, they used it for creating scripts. And then there came the Bourne shell. This was Bourne shell by Jason Bourne, no, Stephen Bourne. Okay, Stephen Bourne. Yeah, and yeah, maybe now again, let's guess again. What year? What do you think? Immediately after 71 or 70? Yeah, right, nearly 1979. Awesome, yeah. And yeah, so I have just to check again a little bit my notes. So actually there you had advanced control flows, which is nice because now you have really for and if and switch baked into the shell itself. Then of course you got vars and even the Unix environment was introduced only with the Bourne shell. And finally, signal handling was also one of the major things which was introduced by the Bourne shell. And at the same time, there was another shell which was introduced by Bill Joy, exactly. You know what? Which one? Yeah, well, C shell. I see some old timers are here as well, like me. So C shell was actually created at the same time, and the idea of C shell was to create something which looks similar to C, the programming language. So all the control structures as we know it today for shell, in C shell really looks like C control structure. So if and else, they have really this kind of round braces around the conditionals. And so it was really a kind of a C-like syntax. But the other stuff which really was also useful actually, not only for syntactic sugar, it was they introduced aliases, which is used quite a bit. And even more, the C shell introduced a history of commands. So if you're on the command shell, you know you have, if you make it interactively, you have histories parameters. And also very interesting, C shell tilde comes from C shell and not from the Bourne shell, which is just a reference to the home directory of a user. Yeah, and then there were other things like job control, for example, also quite nice. So putting something in the background and the foreground, this was good. And now let's go to the last shell, which I want to make in this brief overview. This was, of course, the bash, born again shell. And this was written by Brian Fox and so C shell was the same year, 90. So, and I just tell you when bash came in. This was now 1989. Yeah, what you got with bash, you got CLI completion, you get brace extension, parameter substitution, brace extension, and yeah, also interesting, which you can nicely use for error handling. It was trap, which just executes a certain command in case a certain signal happens or when your shell script exited. And yeah, that's it. And here documents were also introduced by bash. And many, many more things. And then bash 4 came along and introduced even more features. So what you see here, it really depends on the set of shell you are using, what kind of features you have available. This is quite a big problem if you go to shell. And if you want to write shell in a very generic way, this is quite hard because it's not only, it's also because the shell has different syntax, but also all the commands the shell are using, which are external commands, are different from system to system. So we will see later how we can deal with this problem. Okay, and then finally there are other shells. I don't write them down. So like, for example, TC shell, which was the successor of C shell, and the T stands for 10x, which was kind of a Unix flavor. And yeah, so they worked on but the branch of the C shell stuff really died out. So these days, most of us are really using a bash Bourne shell kind of derivative. And there were corn shell, which was a commercial variant, set shell, which many fancy hipsters nowadays use for the command line. And yeah, you know what I mean. Okay, so this was a quick overview. I think it's always good to know where we come from. So shell itself is nearly 50 years old, which is quite a bit, really. And it's still alive. And this is really one of the main surprises for me, that you still have nothing better like that. Okay, let's get started. What do we want to do today? So the idea is we want to write a short shell script, and this is a typical use case which we encountered. So actually this example comes from the Kubernetes world. And you know, you have Kubernetes, you have a command line tool, it's kubectl, kubecontrol, however you want to call it. And this allows you to have some kind of client commands, but not everything can be done with kubectl. And the idea now today is that we want to introduce a new command called kdeploy, which is about implementing canary and blue-green deployments. So you know that in Kubernetes there's a kind of deployment objects, and it supports certain ways how you can make an update, like a rolling update or a fixed update. But there's no direct support for things like a canary deployment, where you only have where two versions of your application are running at the same time, but one version only serves a certain, very small fraction of the requests, so that you can try things out and either update with the whole version later on or make a rollback. So, but we do not implement it fully. We just make the shell around this one. How we would do it actually. The hard work is then up to you for as homework. Okay. So now let's get started. So I have to took off my things. So let's create a new file. Let's call it kdeploy. No, sorry. When I save it, let's call it kdeploy. Like that. So, and actually, for the sake of example, we are using bash. So actually, as I said, you can. The problem is if you stick to a certain shell, you sooner or later will start to use features which are only known to this shell. So there's some overlap. But at the end, it's not so bad. So bash is also nearly everywhere. So let's just switch over to my syntax highlighting. Okay. Yeah. And then probably one of the most important things is to enable certain flags for bash if you want to make serious coding. Actually, you know, a shell script is a kind of a list of commands which go one after each other. But actually, if one of these commands fails, then the shell script normally just continues. It just runs on and on and on. And you maybe, if it happens in the beginning of your script, you do not even find out that it's broken there. So you should set an option, it's called -e. Which means that as soon as one single command fails in the script, the whole script is broken, stops. This is important. And then you should also use -u, which means that the script breaks when you use an undefined variable. So this is a very, very neat option, because very often you use local variables. You give them a name, but of course you sometimes mistype them, typo or something like that. If you don't use this option, it's just an undefined variable. So, but the script itself continues. If you use -u, then the script also stops with an error if you use an undefined variable. So you should really define them. And defining means assigning something to them. So it's not like that. And then there's another one, which is, I'm not 100% sure whether it's very specific to bash, but I think so. So it's not this kind of option set -o, and then you can add some kind of a custom option. Yeah, there's a question over there. Pardon? It's too dongle. Okay, let me try. Okay, now I need some help from some Atom users. But we can do another way. Let me check that. Now, as we said, we are ninjas. Let's use VI. So, is it better? Oops, sorry. Nah, damn. No, not better. Just that. So let me create another one. Sorry, item profiles, presentation again. Bigger, 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 bigger. That's ninja. Zack. Oops, yeah. Okay. Just let me close it on the other side. Okay, here we go. Okay. So, Z -O pipe fill. Yeah, question? Yeah. 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 Typically is if you use a minus, an argument starting with minus, which is always an issue for many commas, not only grep. There's, for the most option, there's an extra special comma which is called -. And this simply marks the end of the arguments. So after that, you can use -e. So grep -, space, and then minus EU will grep for something like that. Do you know what I mean? So actually, okay, we are in the shell, so it's without. So if you want to grep for, let's say, grep minus EU here, something like that, this will fail. Yeah, probably not really. So actually, there's an issue, but you want to grep for the whole thing. But if you use it like this, you only find this minus EU. What is about your question, or was it because it doesn't? Mm-hmm. Yeah. Yeah, actually, yeah. So this is an issue, and typically, when I do that such thing. So if you use it in an if, it should be not a problem, because if you use it in a conditional, it's okay, even with minus e. Huh? Yeah, but it also depends on grep. But just tell him my solution for that. This is also a solution. So I just make a temporary set plus x before, as a set plus e before I use a grep, just to allow the error and then evaluate the return code with 1. Okay, this is a workaround, of course, and maybe you should then what I didn't quite get the answer. What suggestion you give? Okay, pipe true. So like grep. So let's say blah blah blah. It's then kdplay and then pipe true. Yeah, the problem is if you use this set minus o minus pipe fail, then it still fails. Yeah, because this is what I wanted to explain again. Let's go back here. So here, if you use this minus pipe fail, which is also quite important, it means that typically if a pipe, in a pipe when a command fails, then it continues with the next command in the pipe. But if you use set minus a pipe fail, then the whole pipe fails. Yeah. Not 100% sure. I'm not even sure whether this is POSIX or not. So POSIX is a kind of a standard for shells, and some shells are POSIX compliant, some are not. But I'm not really sure. I would have to look up. So for standard shell, I'm even not 100% sure whether there's a bash feature. So, but I use it always. So sorry for that. Okay, thanks. Okay, so this is something actually this you should do always. Actually, if you want to write long scripts, if you have only a short snippet of script, maybe it's not necessary. So let me git stash check out line. Sorry for that. Okay, this is now my thing. And what I also normally always do is really to store the arguments to the script itself in a variable. The reason for this is that because if you continue in the script, this kind of implicit variable, which is this $@ changes depending on the context where you're running it. So when you're in a function, it's overwritten, so it's always good to store it in a local global variable if you want to re-evaluate your stuff later on. Okay, so this is my beginning. I use this not typically in any script I'm writing. And then the next step is, of course, what we want to do with our script is we want to make it so fancy like all the other command line tools. Like we have a command, we have a sub-command, and we have options on that. So we have a command kdeploy, we will have a sub option which is called green, blue, or canary, and then we have specific options for the sub command. So this is the same like Docker or kube control. So as I said. Okay, therefore we need to pass some options. What I'm going to show you now is actually there are tools like getopt, which is an external tool which is useful for parsing options. But what I'm doing is, because it's actually quite easy, and I'm hipster enough to write this on my own. So actually, I hope that now I'm not sure. Let me make that. So I think because in the back it's not so easy visible if it's so low. Okay. Let's start with, again, over here. So now, as I said, I'm hipster, but not so hipster that I know VI very well. Okay, has flag. Then what you typically use is a kind of a local. Local is also a keyword for functions. So functions you can use functions as a keyword, but I typically omit this because it doesn't have any extra value. You can just use the function name, then parentheses, and then your braces. And let's say I want to check for a flag, and then I check this argument here, coming into the function. So actually, this is good for mandatory arguments. So if this function is supposed to have some argument, then do it like this. If you want to have some optional arguments, you should do something like this, which is an option, which is a bash feature for a parameter extension, which means if $1 is not set, then expand it to an empty string. In that case, if I don't do this and I don't provide an optional parameter, then my script breaks because of the set -u. which doesn't allow undefined parameters. But in that case, we want to have it mandatory. Oh, come on. Here. Okay, gone. Okay, and then for the sake of cycle, so this what I'm used here is I put it into an array, but actually for simplicity reason I just use the array. And then I make a for loop for arg in my given arguments, which are these. Then do, and we are done like this. Okay, so we iterate over all the arguments which has been given on the command line, and then we just check with if the flag, the argument to the function, is the same as the argument. If this is the case, then we just make an echo true. And if it is not the call, then we just make an echo false at the end. So actually, there's some issues. So first of all, we have to check if you use variables. You should always check whether you should quote them or not, because sometimes you need quotes, sometimes not. In that case, I don't want to quote it because I want to expand multiple arguments into a single string with spaces, so it's separated, so it can iterate over all the elements in this space. But in this case here, I really want to. Just because if I have, for example, I have flag or an empty argument, I still want to compare them to each other. Okay, and now let's see how we can use this. So at the end we just make here if, and now we just use as flag and e, I just explain why, minus DevOpsCon, then echo, yeah, okay, good. Now this is one of the major tricks I'm going to show, yeah? I'm missing where? Ah, yeah, thanks. That one? Yeah, okay, thanks. So actually this is one of the main thing I want to show you is if you use functions like I do here, and you should of course use many functions because you should not use a very big functions but split up everything in smaller functions. This is good practices if you're coding. Then you only have typically a numerical return value. You can return a return code like 1, 0 or something like that. But if you want to have something more fancy to return in a shell function, like a string, you can do this as well, but in that case I'm not really calling the function directly, but I'm evaluating in a subshell, which means I'm calling this and I get back the output of this function and use it here directly in that case. So if I return true, then true will be replaced for this part here, for the evaluated part. True, but true is also a command in Bash, which means true, which means that the conditional works like this. If it's false, then it's false. So actually I can use exactly this kind of construct just to check whether the flag is there or is not. Is it clear somehow? So the big idea, the thing is really that you use eval, like with this $ brace parentheses, just to get back the standard output of the version. Okay, let's try whether this really works or whether so bash kdeploy minus blah, so test it first, so nothing happens. Minus DevOpsCon. There we are. Okay. So this is an easy way, and we can do this the same for reading options as well. I have something prepared, like a good chef does. So I have here, okay, git stash array, git checkout to, so load. Okay, so here we have our flags. Here it's a little bit more involved than I have shown. Actually, what I'm doing here is really I allow multiple options. So I actually allow, you can use minus DevOpsCom or minus DevOps or anything you want. You can provide multiple options as arguments to this function. So if any of these fits, then it returns the value. And the same thing is for read opt, which just where the important part is where we're going here. We are checking whether something starts with the option which has been provided as argument. For example, if I use minus hello world, or hello equals world, then I would check for minus minus hellos and if anything else. And then there's another neat trick which is here about how I make regular expression matches with bash itself. So it's only about with parameter substitution. This is a bash feature which says here replace the part $opt equals with an empty string in that case for the variable, and then I get the value. So actually the value is everything after the option. And then I just check whether the value, if something has been replaced, so in that case the value would be unequal than the variable itself. And then I make again this echo thingy, echo value, and I can just go upward. By the way, if you want to know, actually I don't know these by heart, so I have to look it up all the time, how this kind of parameter substitution works. And my favorite page for that is actually not that one, which is, I just paste it over, so it might be easier, which is from the Linux documentation project. So this is actually this is the one which I really, use all the time. Not sure whether there's something better, but this is my personal one, my personal favorite. Okay, let's continue. Nothing found, then nothing. And then finally we came to a method which I also use all the time, which is called basedir, and which just gives you the directory where the script is located in. The reason why we need this is later on when we make this subcomments with our shell script. So basedir just checks out the source file, but it does also some neat things like checking whether it's a symbolic link, like here, and then tries to resolve the symbolic link. And unfortunately for symbolic links, it's really a mess in Unix because there are so many different commands to find it out. And even these commands have different kind of options, which are different on OS X, on Linux, and so on and so on. And okay, then you have two options. You can, if you want to support all of them, you can either check, for example, for the operating system and do some special thing. But actually, this is not very robust. So much better is to make feature probing. This is a thing which is shown here, where you just try out several commands and take just the one which works. So in that case, there are three variations how you can read a symbolic link, and it just goes over the list and check the return value of this command. And if it works, then it just fills in the variable script. And then later on, if it doesn't fit, then it calls something which returns you a string with like this, an error string. Okay, and then at the end, if I have the script, I check the denom, and then also I just make really a cd into that and print the current working directory, pvd, and then I make and then print out the full path to this directory. That's the way how you can get the full path, even if you are currently specifying a relative path. Okay. Took a bit to get out this function, so this is one of the takes some time to get it right, but I think it's quite robust at the time. Okay, yeah. 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 Minus -a, yeah. This is something I'm also was surprised of, that it works. Yeah, actually I haven't really checked it completely, but my thinking is that it really, if you use a conditional like if, then it temporarily switched off the set -e. But I'm not 100% sure. I'm using this, and when I prepared the talk here, I was really surprised that it works. So actually, because of this reason. But yeah, it works. Okay. Good. Now let's go on to the next step, which is now let's do something. We said, okay, here what you see here is that we are. Maybe I can make it a little bit bigger because the script is larger. Here you see how you use it. So if the flag is -help or -h, then I just print out the user's message, like it's supposed to work. In that case, you have a subcommand, you have options, and so on and so forth. Okay. But now let's implement a function which is called, let's call it run, which is just, which we call like here. And now we say, okay, we name this kind of comment, which is a subcomment, is just again the first variable. So we suppose a format that the first one is just a subcomment, and then we just check something like if -f. So basedir, you remember the thing which get the directory where our script is located in. Then we create a thing like comments, which is a subdirectory, and we check whether this exists, this comment. Maybe like that. So if this is the case, then we have our command, our kind of module, nicely localized in an own script. So we can make a source of, you probably should put this in a variable itself, base dir comments, like that. So you can always put it, also everything into the quotes or only the part which you really want to quote. So source just includes the script, and then we make an eval on a thing which is called comment $run, something like that. So we expect that this script includes a function which is called, like the file itself, $run. So let's try that. So we have to create this kind of structure, make dir commands. I'm not sure, I'll check later. Then we go in and then we say canary, because our subcommand should be called canary. We can also, so this is not 100% necessary, but we can call it like this. I'm not sure how to switch off. Yeah, better. Syntax highlighting. And then we have one which is called a function called canary. I'm not sure. Canary run. Echo canary deployment. Okay, now works. Now let's go up. Just check again the thing with really it's commands or command. I'm not sure. Have to go down. Commands. Okay. So we should be good. And this is an easy way how we can modularize our application, our script. So if you have many script parts, and also actually, you do not have to use this double columns there. So this is just a convention. It's also only allowed in Bash as a function, as part of a function name. So if you use another shell, you should probably use underscore or something else. But just try whether this really works. Bash kdeploy canary. Doesn't work. Very good. So now the next point is how to debug such stuff. Yeah, good point. So what you can always do, and this is very nice, you use -x. So -x is the same like set -x, but just prints out everything it does as on a command level. You have some kind of indentation with plus signs here. And yeah, the reason is of course that I do not call run. Yeah, you see? So I have defined run as a function, but I don't call it. So let's fix that. So again, we just going down. There's run. So we have here, we have to call run, and we again use our argv on that case. Yeah, args it calls. Yeah, thanks. Args, and I think it was. I'm going back because I'm using in that example. I use really use an array. Yeah, I use an array, so I have to use. I always forget the syntax for that one. To expand everything. I think it was $, something like that. Not sure. We will see in a second. So you see it's quite, no, it doesn't work. And why not? Let me check. Echo false. Fail on error, undefined. No, this is from my comment. Actually, it's interesting why it calls flag. Okay, because I have no flags. Let me check. Because you see, it's a little bit difficult here with the small screen, but I have this run. Args should work actually. Just for the sake of demo, I just remove this one, make this again. I just use $* here directly because it's not used already. Something like that. You see. Here we go. And if I use something different, then it just fails again. Okay, this was just an attempt. Now let's get rid of this one and check out the fixed version. Okay. Remove comments. 3 comments, and now look again. And as you see, it's a little bit. In the full version, you see a little bit more. So we have our base tier here again. Then we have the main loop, which I just mentioned. And again, it checks here the first arg, but actually it also checks whether the first arg is really an argument. So it does not start with minus here, which is that check. And if that's the case, then we do exactly that, what we just have done. We just check whether the file exists. If it doesn't exist, we just print the help message, because we know then it's not known and it's an unknown command, and so we have mistyped it. So it's always good to introduce this kind of help support for your users. And again, we check for help, and finally we make this kind of sourcing and exactly this kind of eval. So the idea is the same here. And yeah, so we are good now. We can add now many other commands directly to this, like for example a blue-green deployment. But the next step is what we are going to do, and I'm showing you already the version, the version which is prepared. Now git checkout for help. So again, our thing. So actually, what I've done here now, I have these functions all directly in the main script. Of course, if you like, you can put this also in a kind of a utility module where you put it in and you source it there. And let me go scroll down. Sorry if it's a little bit fast. So we have our run. So this is everything the same. But actually, we have, if you're using the help command, we're also checking now. So actually, if you use kdeploy subcommand --help, it should not list or print the help of the kdeploy command, but of the subcommand. So each subcommand has an own help page. And you can easily do this by, again, the same trick. You go into this directory, you list over all modules you have in there. Again, you see you make eval, then you iterate over each of the commands, you source every of these commands and print the description of that. And the same then exactly. So this is the case if you write help without any option. But if you provide a command, then it only sources this very command and prints out the description plus some extra usage measures. So now the API is like that your module should support 3 functions, namely run for running it, of course, then a short description for showing a minus description, and then a usage page for how it works. Okay, let's have a look into the command, then we run it. This was canary. You see, we have here canary runs. Actually, this is still a kind of a placeholder, a dummy. We have the description, and then we put in all the stuff which we want to do. We want to have parameters for the name of the Kubernetes deployment, which we actually want to deploy. Then the image reference for the new version, for the canary version, how many replicas of the full deployment should exist, and then some kind of erasure, which just in that case tells you how many canary releases should be deployed compared to the old release. Okay, and if we try this out, so we here again, we can call kdeploy canary kdeploy. So if I call kdeploy, it lists all the commands which it knows. Actually, really makes it dynamically out of the thing which is in there. And if I call kdeploy with canary --help, then it does exactly prints out the options for only for the canary deployment, plus the description like that. And if I do nothing like that, then the canary deployment happens. So that's it. Actually, we found out this is quite nice because you can really separately work on this command. So we have, as we said, we have in my tooling, we have something like subcommands like build, like deploy, like test, and so forth. And this works out quite nicely if you make large shell scripts. And now let's jump to the last part. So actually, one important thing is about error handling. So how do you deal with errors which happen there? So you make an eval. So eval itself, the error code there is also erased somehow. So you don't fail actually if you eval something when the command fails. So your set -e doesn't really work there. So how do you deal with errors? And the one thing is what we are doing. So now let me check out that. So this is not good. Let's not check out 6 testing. So this is okay. Yeah. So let's go to the commands, and then I have something which is canary. So what we do, this is a kind of a convention. So here I have a little bit more, put a bit more flesh into the run thing. So actually what the algorithm would be, if you would implement it, you would check the deployment, you would check the image, you get the old deployment. So this is a kind of a JSON YAML file, which you use with kube control, get something -o JSON. And then you massage this deployment descriptor by replacing the image, giving it a new name, and deploy it as a new deployment with the number of replicas you want to have. So this is roughly the idea of this kind of algorithm, but as I said, it's not what we are going to do here. Interesting is here what I do here. So actually when I call out to a function like that one, and it's empty, so we already said, so in that case deployment would be really a mandatory option. Then I return an error code value, a string value, which begins with error. So the convention in my script is to use my error column as a prefix and check afterwards whether this prefix is given into the return value. And if this is the case, then it's an error. Very simplistic, but works really quite well. And then if you use it like here, so like here, what we do, there's a method called checkError, which just checks whether this value which is returned for this get deployment begins with an error prefix. And if this is the case, then it exits with 1. So it stops the script and prints out the error message. It's a little bit like the way like Golang does. So actually, if you know Golang, it's always there that you return an error value and then you always check it. It's not an exception handling. It's just really like check the return value and check whether it's an error. And if you propagate this over the whole chain, this works quite nicely with this kind of eval style of returning values. How does this check error looks like? So I added it to this command here, but typically, of course, you would add it to, so it's very easy, simply. So you take all the arguments and you check just, so this is a shortcut for a regular expression matching at the beginning of a variable. So this one replaces every error at the beginning with nothing, with an empty string. And if this then, and you can check for the match, of course, if the string before and after is the same or not. So if it's not the same, then it's a match. And if that's the case, then I make an echo message and then make an exit one. Okay. As I said, it's a very simplistic thing. It also actually works only quite nicely on the top level. So if you're really on the top level of your shell script, it's not if you have an eval of an eval of an eval, then you need some other issues. So what we are using in that case, we are storing that in a kind of a temporary error file and evaluate the error file at the end. So we write everything, every error, append to an error file and then check whether there's something in the file. If that's the case, then it's an error on the top level. So this is how we jump over several levels. Okay, now we have 15 minutes left, then I have some final part which I really would like to show you. This is about integration testing. So actually you have now a bunch of shell script and obviously you can test them interactively, but as they're growing, of course, you want to be sure that nobody else breaks it, and especially as everybody thinks he knows a little bit of shell script, which is true, and is also encouraged to work on the shell script. It's even more important to have some kind of testing there, because not everybody uses the same convention, something like that, and make the return values. And yeah, let's see how we can do testing with a very short, because I just think I just forgot one minor piece. I just jump into there before we go to testing. What I found very interesting in parts, so this is something you just can copy over. If you use -x, we have seen that we can, so this bash -x or set -x is the same. You see, we can see the execution flow of all the comments, but you can do with bash even more. You can prefix them really with the name of the shell script. So if you use many scripts and include them, then you could get really the name of the file name where the shell script is. You can get the line number where this happens. This is very useful. So if I use, for example, here, kdeploy -- verbose, because I added it already as an option, and then canary something without deployment. You see, it looks a little bit even more verbose, but you see exactly the file, the line number, and the function name where this line happens, which is very useful if you're in a very large script and have a big context here. Okay, now you see that there's another error. Okay, now let's check the shell scripts. Now back to the real thing. So there's a framework which is called BATS. Who knows BATS? 1, 2, awesome. So BETS is a very old one. Actually, it's has been created in 2014, and it is not developed anymore. So there's no support, but it works. So actually, in BETS is a kind of a framework. Think of it like JUnit for shell scripts. So it's not only for integration tests, but also for kind of unit tests. And you can write, so BETS you have to install. This is an external program. So BETS, you can find BETS. Oh no, I've lost my shell. So I have to give me. So it's directly go on GitHub, search for it, and you find it. No, I have to find a repository. But I'm to GitHub BETS, even better. Sometimes Google is just better than GitHub. Okay, this is the one, and it has a very simple API. So you define your test like this special notation. You use BETS as a command line. This is interpreted by BETS, and then you run your code in there and make call of assertion. So if any of these commands within this block here results in an error, which means in a return code unequal to 0, then it's an error for the unit test. How would we use it in our script? So let's go back. So what I have here a test directory. So I have already some. What I typically do, I use some kind of test helpers. There's also on GitHub, which is called BETS asserts, which is also kind of a helper scripting library which you can reuse. And what I do, just have some methods like assert regapps. So I have some assertion methods which I'm using just to check the values and the return values. And then I have my test, like here canary BETS. And what I see here is I have a command which is called run. This is a part of BETS itself, and this runs then this script. The directory of the script itself is of the test suite is given also in the specific environment variable set by BETS. And then I call it with canary image blah, and you see I forgot the deployment. In that case, I expect that the return value. So the return value is stored in local variable status, and the output is stored in output. So I expect indeed an error. So that therefore I expect a return value of 1, and I expect that the output contains certain keywords because I want to give my user certain context when something is wrong. Especially I want to let the user know that he wanted to do a canary thing, that there's no deployment, and that he had to use the option minus deployment. So it's always a good way to, if you check for error messages or for some stuff like this, don't check for the full error message. Sorry, for the full error message, because this is very fragile. It's better to check for only those parts you are really interested in, that they are present, like that the user knows how he can fix the bug, the issue, what's happening, and what he has just done. So these are the rules which you should think about if you make error messages. Okay, and then I already did here the same, but of course we could do the same with image. So I could just zip that. So I just remove that. Of course, this is a little bit fragile, my error handling, because it depends in which order I evaluate the options. Okay, no, in that case, no image. I want to see. And also again canary. Okay, and then you just call, as I said, you go in the top left, you say BETS, and then you just call the argument with a directory which holds the test suite. Okay, there's an error, and you see that so an error in the test. So actually, this test passed, but the other one didn't pass, because it expected there's no image inside. And you see that I probably that's okay. Now let's see how the error message really looked like. You can just do it on your own by using kdeploy minus deployment blah, and I see there's an error. Okay, very nice. Thanks. So actually you see that it's not very nice error message, and I would expect, of course, to check whether there's a comment is given. If none is given, then I use either a default comment like help, or which I should in that case, or use something other which I say is a good choice for a default comment. So you see, yeah, because this is also something which could be improved. I expect an equal sign for the option. Of course, sometimes you use just a space. No new image given. See. Okay. This might be, now I can either fix the test or the error message. I fix the test. Canary. So you can like that, or you can choose the thing, and then we should again bets test test. Still not okay. Okay, next point. This is also a trick which is not very obvious. What we can do to just to see what has been seen in the test, we could just go into that, and we could say, so if a test fails, it just writes everything as there. So I can do like this: output equals $output. So as I said, $output contains the output of the command under test, and in that case, it will print out also. But I have to put it before that because otherwise it breaks. So let's see whether it's true or not. No, it doesn't. It's not true. But no image given. Maybe I should do an echo output. No, of course I should try that. So it says it's very rudimentary, and yeah, you see that it's another different error here. So this is what is now printed out. So actually I have something wrong in my test itself again, and the same reason is that I forgot to add here some stuff. And you see the script itself is not really very robust because it should not depend. Actually, it should mention that both is missing, not only the first one. But for the sake of simplicity, it's just like this. Everything's fine, test is running. You can easily add it to CI, you can put it in a Docker container, you can change your shells. For example, it's also very nice if you want to write a shell script which is usable by different shells, not only bash. You can, that's what we are doing, we create different Docker images with different shells, and you can switch the shell in the tests. And this is very, very nice, because then if you develop shell script, you are not sure whether it really works on every platform. And if you have a good integration test suite, this will help quite a bit. And it's also, if you're running for Mac, it's different maybe. So it's really, that's a big problem with shell scripting, is really that it's so undocumented, so volatile, so it's really hard to prove from the beginning that it works. So the only thing how you can prove that a shell script is working is to run it on some system. And even then it can fail on another system later on. Okay, so I think that's all I have for now. So to summarize, I think shell scripting itself is it's still tedious. It's not really super fun like a real programming language. Actually, shell scripting is not a programming language. But you can, if you follow certain conventions, you can make it look like a little bit like a language, like a programming language. You can use some common themes like integration testing, error handling, propagation, like methods with return values. You can split things down. And you can write a lot of very big scripts like this and quite robust things. And I really recommend to use testing just to be sure if it's done. Okay, there are questions over there? Pardon? Not yet, but I'm going to make a GitHub. And if you follow me on Twitter, so my Twitter handle is... No, I'm just telling all of the organizers. So if you, but you can also just monitor that one or monitor my repository. Then I'm propagating this. Give also pointers to the big scripts which I'm developing, which maybe even other tricks can looked up and see on. Okay. Other questions? Yeah, there's one. Because I wanted double dash. So actually, I wanted to run it on GitHub is also something which is very different on different systems. It doesn't work always the same. And yeah, this was the main reason. And actually, the other reason was this. Yeah, I know. But it's for all the stuff. It's probably not. And actually, the main reason is that this part was not written by myself. So actually, I probably would look more deeper into it. I've seen that it might make really sense to don't redo that sort of stuff. But actually, the point here was not so much this function itself, but more how it propagates the methods that the return value is back. Yeah. Sorry, say it again. It was a little bit low. Yeah, that's also a good question. Yeah, because I can do... No, just kidding. Yeah, case would be a perfectly valid thing as well. Yeah. No. There's no real reason for that. You're right. Correct. Okay. Okay. Any other questions? Yeah, there's one. Yeah. 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 Options not really mandatory. Yeah, true. From a UX point of view, it might make sense. So actually, but this is also the case for from many other tools, which require you could also have done sub comments, but then it gets a little bit. Yeah, it depends how you do. Yeah, exactly. Yeah, actually, yeah. But I would probably back this argument. You should don't call something mandatory as an option. Yeah, true. Okay. If there are no more questions, then thank you a lot and enjoy the rest of the conference.